Alrighty, we're here for worksheet 11D for the Math 4 course. Coming down the home stretch, the Unit 11 review is going to be the last worksheet that y'all have to do. So anyway, I thought this was, I'd always seen these, and now it's the appropriate time to use it. All right. Of course, if it is squared, that means we are literally talking about that times that. Now, if you want to have some fun, we can do that. A plus B quantity squared equals A squared plus 2AB plus B squared, but we're going to do it the old-fashioned way. All right, so we got equals 64 plus 112I plus 49I squared, which means that this is like 64 plus that minus 49. 64 minus 49 is 15. And bada boom, bada bing. Oh, for funsies, let's try it the other way. A minus B equals A squared minus 2AB plus B squared. So that is going to be 8 squared minus 2 times 8 times 2I plus, plus 2I squared. That's going to be 64. 2 times 2 is 4 times 8 is 32. And then 2I quantity squared is going to give us a 4 and an I squared, which is going to be like that minus 4. 64 minus 4 is going to give us that for a final answer. That was fun. Now we're back to the box again. -1 minus 2I. Got to watch your signs here. -1 times 3, -1 times 8I, -2I times 3, -2I times 8I is -16I squared. So we're going to have -3, minus 6 minus 8 is minus 14I. And minus 16I squared, well, the I squared is a -1, which makes this a plus 16. -3 plus 16 is 13 minus 14I. Four minus 3I, 6 minus 6I. 6 times 4, 6 times -3I, -6I times 4, -6I times -3I equals a positive 18I squared. -24, -18 make -42. And the 18I squared becomes a negative minus 18I, or excuse me, minus 18. 24 minus 18 is 6. And that is it. Oh, that looks cute. Well, we could say negative 8i squared times negative 8 plus 4i, which negative 8, that's negative 8 times negative 1, which makes this an 8 times 8 minus plus 4i, which if we distribute, the 8 becomes negative 64 plus 32i. And we're done. This one will involve somewhat the same. If I put those two together, I get a negative 16i times negative 5 minus 4i. And when I distribute that, that times that gives me a positive 80i. That times that gives me a positive 64i squared, which equals that. That's a negative 1, so that's going to be minus 64, and we need to leave it in proper form. So it's going to look like that. Remember, the I term always comes last. All right, now we get to play with some conjugates. This one, if I have a 3i on the bottom, I'm going to multiply by negative 3i, top and bottom. Distribute that, it's going to give me this, and negative 27i squared. And down below, we're going to have a negative 9i squared. So this, the I squared is negative 1 times that is going to give me plus 27. Negative 1 times negative 9 is going to give me that. And then we're going to switch it around the right way. And then we're going to say, hey, 3 will go into everybody. Or we could write it this way. All right, the conjugate here is going to look like that. Now, when I go over here, negative 7 plus 6i, 7 plus 10i. And so when I start multiplying in here, that's going to give me negative 49. 42 minus 70 is going to give me negative 28i. And then plus 60i squared, which is going to be that and that. Negative 1 times 60 is going to give me a minus 60. And when I say negative 49 and negative 60, that gives me a negative 109 minus 28i. And that's what the top is going to look like. And then on the bottom, if that is A and that is B, then A squared plus B squared is going to equal 7 squared plus 10 squared, which is 49, plus 100, which is 149. So that's what that's going to look like. And I think I'm going to leave it that way. Those fractions would get big and ugly in a hurry. And I'm almost certain that they're not going to reduce. 149, 7 will not go into it. 3 will not go into it. 5 will not. 11 will not. And I think we're about out of prime numbers by then. Um, so that is not going to reduce because I believe 149 is prime. All right, this guy we're going to multiply by 6 plus 5i on the top and on the bottom. So here, 4 minus 8i, 6 plus 5i. Twenty minus 48 is negative 28. Negative 40 times negative 1 gives me a positive 40. 24 plus 40 is 64. And then meanwhile, we're going to have a squared plus b squared, which is going to be 6 squared plus 5 squared. That is 36 plus 25, which is 61. And 61 is prime. So nobody's going to reduce there. All right, number 10, we are going to multiply by negative 6 plus 9i. Now, I want you to notice something here, that with the conjugates, it is only the sign in the middle that gets changed. You know, the negative 6 up front, that's not what's going to change. It's always about the i's. Notice that when we had only like a 2i underneath the bottom, we did a 2i and we did a negative 2i because it's like 0 plus 2i, 0 minus 2i. Your real number is never going to be a conjugate in this sense. You know, when we're doing the a minus b, a plus b, that sort of thing, it can be a conjugate. But when we're dealing with complex numbers like this, the conjugate part is always the I. All right, so let's do the top. Negative 5. We have plenty of negative signs to keep up with here today, do we not? All right, so we get 30, we get 6i, we get negative 45i, and we get negative 9i squared. So that is going to be 30. Negative 45 plus 6 is negative 39i minus 9i squared, which that 9 is going to become a plus 9. 30 plus 9 is going to be 39 minus 39i. It is funny how sometimes you will see numbers that relate to each other like 39 and 39i. It's the same number. And there's absolutely nothing about the placement of these numbers and the i's that would predict that you would get an answer like that. All right, let's see what's going to happen on the bottom. If that's A and that's B, and I take negative 6 and square it, and I take negative 9 and square it, that's going to give me 36 and 81, which is 117. Now, as it turns out, 3 will go into all of those. I can tell that because if you add the digits, 3 plus 9 is 12, which is divisible by 3. 1 plus 1 plus 7 is 9, which is divisible by 3. When you add the digits, if that number is divisible by 3, then so was the original number. So I'm going to get 13 minus 13i. 3 will go into that 30 times with 27 left over. 9 goes into 27. That. Oh, that's interesting. 13 goes into these numbers. Is that really? Yeah, it is. 13 goes into these numbers. Which means 1/3 minus 1/3 I. How curious. Any one of those answers are technically correct, but at some level you try and reduce as best you can. And I guess 39 is a factor of all of these. 39 goes into 117 3 times. And of course 39 goes into 39 once. How curious. All right, here we have just a negative 6i underneath, so we're going to multiply by a positive 6i. And when we distribute, we get that, and we get that. And this times this gives us negative 36i squared. Now, the I squareds are going to change the flavor of this. Minus 18 and positive 36 on the bottom. And of course, we're going to switch the order. That was a negative 18. Negative went with that 18. That negative went with that 6i. And 6 will go into all of these. So I can literally say negative 1/2 minus 1/6 I. 3/6 is 1/2, right? Okay. Number last. And this is going to be one of those where we're going to have a party at the top and the party on the bottom. So starting out with the party on the top, negative 7, 6i, 10, negative 5i. $35i and $60i make $95i. Negative 30 times negative 1 gives me that. Negative 70 plus 30 leaves me with negative 40. And so that's going on top. Negative 40 plus 95i. And then underneath, we're doing a and b. We're saying a squared plus b squared, which is 10 squared plus 5 squared. Now, when we look at those three numbers and we say, is there a common factor here? Well, they all end in either 0 or 5, which tells me that 5 ought to be a common factor here. Or we can say that plus that, either way. That is worksheet